Hello, General Chemistry. This is going to be our last video on ionic compounds, formulas, and naming, and we are going to discuss polyatomic ions. Now, what a polyatomic ion is in the name. The prefix poly means many, atomic means atoms, so this is an ion made of more than one atom. This is new. We haven't done this in the videos, at least. And so, what does that mean? Well, that means instead of just one element being the cation and one element being the anion and them coming together, what you have is a cluster of elements, a cluster of atoms that have come together, and as a whole, they are an ion. So the ion is a big chunk of atoms together, and they all act as a group. They together form one ion. And so some of the things are similar. In fact, the naming rules are very, very easy with polyatomic ions. So let's look at this. Our first problem, what is the name of CaSiO3, C-A-S-I-O-3? Well, one way that you can tell that this is a polyatomic atom is that there are 3 capital letters. Every time you see a new capital letter, that means a new element is involved. So this has 3. It has this element, Ca, it has this element, Si, and this element, O. And we have to figure out which is the pairing. It could be CaSi or it could be SiO. Well, we have to look. So let's find Ca. Is that an element? Well, it is. We can look at our periodic table right here and see that Ca is calcium. So we're gonna see if it's calcium. Calcium. It's an anion. It's a cation. So we can start the name with the cation. So if that's how it's broken up, then SiO3 should be on the back. So we have on the back of your periodic table a list of the polyatomic ions. These are the polyatomic ions that we're going to use in class. So I'm never going to throw a polyatomic ion that isn't on the back here. So let's see if we can find Si3. And it turns out that we can. If we look in the second column, the -2 column, we can see SiO3 right here, and it is called silicate. And that's it. That's how you do namings of polyatomic ions. It's actually pretty simple. You find one part, you find the other part, you put both of their names down. There's no IDE ending. It's actually more simple than the simple ionic compounds. You just write down their names and you're done. So, we'll move on. What is the formula for magnesium phosphite? Well, here we do everything like we do before. We find the symbols. So magnesium, that symbol is Mg. And now we have to look in the back for phosphite. Phosphite is a -3 ion, and it is PO3. That is the symbol for phosphite. So now we have our 2 symbols. Next, we need to find the charges. So to find the charge for magnesium, we look at the periodic table. Magnesium has 2 valence electrons. It has a low electronegativity. That means it's going to lose electrons. So if it has 2 valence electrons, it can lose 1, 2 before we go down to its next full shell. So it's going to have a charge of +2. Phosphite, well, we can't look up the charge of phosphite on the periodic table. We have to look it up on the back with our polyatomic ion list, and it is -3. So we balance these. We're going to need more magnesium. Now we've got +4 to -3, so we need more phosphite. Now we have -6 to +4, so we need more magnesium. And finally, we have +6 and -6 equaling 0. So we are balanced. So now we have the count. We know it's going to take 3 magnesium and 2 phosphite. So Mg, Mg3. Mg3. And here's the tricky part for polyatomic ions. That phosphite, we need 2 of them. But if we write PO3, 2, this is not correct. This looks like our polyatomic ion has phosphorus and 32 oxygen, but it's phosphorus and 3 oxygen, so we can't do this. If you need more than one polyatomic ion, you need to put parentheses around the element. Apparently that undid my subscript here on the 3's. So there we go. So now we can add the fact that we need 2 of these, and it shows that we need 2 of the whole thing. And this would be our formula for magnesium phosphite. I hope this helps. Struggle well.